we introduced ES6, the history of ES6, and we looked at some features of ES6. And in this class, we continue, which are modules, promises, and async/await. So right now, most of us have been writing meaningful JavaScript code. There's no way you write meaningful JavaScript code without using modules. In ES6, there is ECMAScript 215 that allows you to organize your JavaScript code in reusable units. They actually promote separation of concerns, better code maintainability. So let's try to look at the structure, the module structure, before we. So each module actually represents a JavaScript file with a .js extension. So the code within, that means variables and functions defined inside of that module are not direct. So you can actually export and import modules so as to reuse them. And without talking too much, let's take a look at an example of, let's say, for example, we have, let me zoom in a bit. Okay. Okay. Let's assume we have a function of add function. And in this function, we have function and b. It simply returns a plus b. Okay, so in this function here, we can only access this function in this file. You can actually call log console. You can access this function in here. The add function, we say 2, 3. Execute this file. Okay, if you execute math.js, n is missing. We get 5 because 2 plus 3 is 5. But we cannot access this code inside of, let's say, index. Inside of our index.js, you cannot access this file inside of index.js. We cannot see log this will not work. If you try to execute node index.js, so for us to access this code in index.js, we'll simply come to our math function and export this function. This is a name export. And then we can directly access it in our import add from math. And if we execute add 3, we get an error. First, did you mean to import math.js? Because we did not script, you must add extension, file extensions to tell the JavaScript system, yo, what I'm importing is actually a JavaScript file. We get our result 5. So in our math function, we're exporting something like export. It is now in the index. Before you use modules in your JavaScript file, you have to specify. So if I remove this and execute this code, you get an error. Cannot use import statement. Did not specify the module resolution, the module type in the packages in CommonJS. We're not using UMD or any other one. We're using module. So if you run this file now, it will still work. Okay, so that is how to use. We now understand what modules are. Maintainable code. And not only look at the basic syntax of modules. So moving on, we look at the module format. And under the module, script lacked a standardized way to define modules, actually. So modules emerged to address this issue. So each came with you. So we have different type of modules. We have CommonJS, which is simply known as. We have asynchronous module definition, which is also known as AMD in short. And we have universal module definition. So first of all, let's look at the CommonJS. So the CommonJS is primarily used in NodeJS environment. So modules are defined by writing code in function that receives the required function as an argument. So other modules. So in CommonJS, we don't use imports and export statements. We use we actually use exports, but not as we use in modules. We add the module object, which can be used to export modules. Then in importing them, we use a require statement, not the import statement. So let's assume we are running module system. We don't have to do this. We don't have to say, okay, export this. What we will do is we'll simply say dot export equal to function add. Now coming into index.js, we say require math.js. Here, what is the error saying? Rename it to use the CJS file extension. Not defined in ES module scope. You can use import instead. The file is being treated as ES module because it has and it contains types module to treat it as CommonJS script. Then rename it to use this. Okay. So the reason why we're getting this error is simply because we're using ES modules. Now, if you run this file again, you get the same error. The reason why is because add is not a function. Here, this is a function, module export is equal to function add. Okay, this is actually an add function. Oops. Why are we getting an error? Okay, we have add, and this is a function like this. And let's run our script once more, and then we'll see our result to be 5. So in exporting named export, and go back to our former method which we exported, you can say this is our function, and then we can eliminate this module exports here. Module is equal to add. But add, this is the name we're giving the add function. This is the name we want to export. Different names. Let's assume we have add to. Then we can say add to here. Then we use this name in the index.js and say require add. And then if you run our function, okay, add is not a function. I'm saying export module, not it's module export. Once more, and we get our result to be 5. But in the case where we have the name, the object key is the same as the object name, we don't have to have a key and the one thing that represents both. Here is add. Now, if you run our function once more, get our result to be 5. And now we're importing it here and then using it in our index.js file. That's how CJS works. The common JS module this is the default module system in Node.js. Now, this is the AMG. This is often used with library like require.js and in the define function, which specifies an array of dependencies and a callback function containing the module scope. So the callback function receives the required module as argument. Okay, so with that, let's see, in our math file, let's say we want to use the AMD. No, I don't want to autocomplete for me. Define. And this is a function that takes in another function. And inside of this function, we have it returns, this inner function returns two things or just one thing. You see, it returns add. And this add, what add? Add is a function, also known as a method in this object, add. What it simply does is returns a plus b, like so. Now moving on to our GUIs, we'll see require. Require. What we want to require is the math file, that is the math module. Now we first of all specify it in this array. The next thing is a function. The first thing is an array that contains the module we want to, the parameter of math. Now math is the name of the module. So math, and then math here is actually all the methods in that module. Let's say we have another method here. This method is, we have another function here that says A, B, but this time around, what it simply does is return A minus B. So we have two methods. Function, actually an object here. We're returning an object with two methods. So in this util.js, this math holds the file name, and this is the math function that holds our code in the math file. So to add is equal to math add. Want to add, we say 2, 3, and we can simply say equal to math subtract yes, subtract 3. We'll simply log add name it result, because after adding it, it returns the result to this function, and this function will variable. Sorry, this is variable. The result of this function will be assigned to this variable, and to simply log to the console. So let's say here should be result 2, and then here we log our result 1 to the console, and the next is our result 2. Okay, so 5, it will actually throw an error. It will do nothing. Let's do JS. We get an error. The ID argument must be validator, internet throw new error, name string, because we're getting a, which is the AMD require MPNI time. Okay, so now we require JS. This is the binary attributable. Okay, but we don't really need to look at the required JS package, node modules. So let's just go back to use it. Now, where do we want to execute our file? So we want to execute our code. Sorry, we want to execute our code in the index.js. So what we do is we import require JS is equal to require. This is a combination of coding methods, because it is using require, which is used in. Okay, now what do we want to? This is we want to require the required JS. In this case, that we install this. What we do is we configure the required JS to actually. What we do is we say require JS .config. It has this config. Okay, so what are we taking? We are taking in the base URL. Base URL is actually required in module resolution systems. Let's say base URL. Name. The name of our file directory. Name of our file directory, and the next argument it takes is node require. The require. Now, let's execute our node index.js, and in our math YouTube.js, yeah. So we've configured it but then we've not used it because in here, this is the utils, but the index.js file is not aware of the file we actually want to execute using the AMD module system. Require.js, and then we pass in an array of the modules we actually want to execute. The file we need is the util.js. And the second function does nothing important. It's actually easy to log on the console like this. So let's execute this once more. Okay, so this time around, you can see module loaded, and we'll see 5 and 1 because in our maths, see 2 plus 3 will give us 5 and 3 minus 2 will give us 1. So that's the reason why we're before we saw this 5 and 1 results, we actually saw back function will execute before this file will be loaded. So if in case it's an asynchronous function inside of the how we can use the AMD module system to work with modules. As you can see, use this define function to pass in another function, and this function contains all your this out of this function. Then we can declare it above. Then we can name it like this. You can name it add, and in here you can reference it add. And if you run our code, we still get the same result. So we can move this as well. Tracks like this, and then we move it up here. This is the kind of, we want our function to be simple. Subtract like this. We get the same result. So, and then remove the name here. So this is an object that actually returns all our, then we can see n is equal to KodeCamp. In here, in our util.js, we can say log n, because this is not callable, it's not a n on the console. At 5.1 and KodeCamp. So that is simply how you can add an array. I want to also let's create another. And in here we can say export. And this defines the type of a function of let's not waste time doing that, please. Because this other functions. So in there, we can actually come here in the index and reference it. We can say test. And now what we can do in our test.js, let's say in our test.js, we are not log n. As you can see, we have code, module loaded, 5, 1, and KodeCamp. So you can in this array, this required JS takes arrays of 5 you want to actually import and use in this index. So that is basically how we can use MD. We can use MD, which is the asynchronous module definition. So moving on, we have, and moving on, we have the universal module definition, the UMD. So in the UMD, it's actually, so what it does is it wraps the module in a self-invoking function that checks, for the presence of define AMD, which is for asynchronous module definition, or module export, which is for common JS. So accordingly, so when it checks, if it's common JS, it exports it as common JS. And if it's for AMD, it exports the module as AMD. Now, the environment without a module loader. So if in case anything happens, oh, fall back to browser environment. We have our almighty ES6 modules. That is a kind of a standardized module system to become available in this generation. So ES6 simply uses import and syntax. So modern JavaScript development primarily relies on ES6 module due to their syntax. So you don't need to go ahead and start doing all of this and all of that. No, you don't need to do that. So let's clear our files and see how we can use modules. And I think we should delete this test file as well. I can go to choose here and do away with this as well. JS, we have constant, functions, and classes. So in this case, let's say we have a constant of export const pi. This constant with capital letters, and pi 1415. We're exporting a constant, and here we can a function to the same file, and this function variables and return the sum of the variables. It actually returns A plus B. And we can also export class, you can say person, and inside of this class, this class has a constructor. This constructor takes in a name, is equal to name, like this. And we want to simply greet the person. This is the name of the person here. This is an object, and this object represents a person. And then this name is the name of the person. I want to actually greet a person by creating a method that can greet. Method, you can simply say log, say hello. So this name, like this. And we can come back here in our index.js. This from the JS, like so. So in here we have I, pi. Now instead we can say log, and if we execute Node.js, yes, I did this intentionally to show you cannot use import statement outside of a and specify this to type module. You can see common JS or module, say module. Do this. So we can see the value of our pi. Now, this is actually, we don't need to invoke it. Now, if you invoke this, JavaScript will not static error catching. There's no any static error catching. Actually, this is a variable, a constant variable. In this code that you get to see errors. And that is where TypeScript comes in. We're definitely going to explore TypeScript in depth and you understand TypeScript. Okay, so now we can actually import our add function as well. Add, but this one is a function and then we pass in the arguments 2 and 3. And we can actually import our person class. And in here, new person is equal to new person. Then we pass in, let's see, KodeCamp, like this. Then log the name of the character. No, we're already logging. In the U2.js, what we're doing in this method, we are saying hello, this done, and we're logging into the console. So we don't need to log it. Call new person dot greets. Then we greet KodeCamp. Hello, KodeCamp. Okay, and we'll export anything. And in here in our U2.js, we can simply remove all these exports. Remove this export key here, and then coming down here, you can say export I. So it depends on how you love to organize your code or how the syntax you prefer. That all exports should be done at the end of a file. But what I normally do is I prefer the earlier. I can also do. I sometimes do this as well, but it's all up to you. You can do something like this. Okay, so you as a default export. But now we've explored all the almost all the module systems, the CJS, and the almighty ESN, which is the ES6 modules. Okay, so now moving with not only the module format examples. So the ES module syntax, we've seen it, and we've seen the name export. This is actually name export, and if you want to import name exports, you reference. What if we have something like, let's just do away with this. What if we have some export default? Let's go with this as well. Person anymore, and we don't have the path. We don't have this class as well. You can say log. You say add 2, 3. So if you execute this, you get an error. And what is the error saying? The required. So we don't have, this is a default export. I can't import it like this. Hence the add here. And now our function will work as expected. Add two numbers. I can actually can say add. And this is one of the advantage of default exports. You can actually come here and say add two numbers, and then you bought two. Okay. Now U2.js, we're exporting it as a default XJS, we're actually importing it as add two numbers. You can actually reassign any name to this. So far, exporting the whole of the file, and if we export default a class of person of name, and if we say this name is equal to name, then we want to say log hello or export. Then we can come in our index.js and see let's say person, this, and here you see new equal to new p, and then pass in the new count. You see, we call the method of greet p greet. Let's capital P, small p, like this. And if we execute this, export anything as default export, and then reuse it, and you can say person, and say person obj like this, and actually, so now we know what default exports are, and we've also seen how to export variables and in testing and trying to understand exports. We also learned how to. Next, we can check out how to import modules dynamically. So how can we import let's, for instance, let's assume we have utils here, contains an for a value to actually be resolved or rejected before it completely running, so it can resolve the error, depending on how you implement it. So for instance, we have export. As you can see, you can also export async functions or async anything asynchronous. You can export it. Export async function. Say it's add, but this add takes in two parameters of A and B, and this function simply promise. And this promise takes in a function that takes in and rejects. This is a function. What is X for type of A and B? So if A, we just want to check for the type. If type of A is not, or type of B is not equal, what do you want to see? We want to reject error. Input must be a number, like so. But if the type of A is number and the type of B is number, we say else resolve A plus B. like this. If it passes the check, we resolve. How do we use it? Now we'll go to our util. This is our util.js actually. Now in our index.js, our function here. What's the name of the function? I think we got it from util. In here we have the add function, which is asynchronous. Is we want to actually use this function now. We create a function that takes care of loading this module. This is a function, and we capture error. We say try catch, and in here also error like this, and in this try block we say const which is equal to await of this okay, I don't even have to import it directly there. And this our function here, what we do here is simply log add, and then we pass in and we'll call our function load a promise. So we can say dot then, and then we execute this load index. Okay, this const add, and then we say await complete its execution. And then we have 5. And the reason why we were getting that, what we're logging is a promise. And by the time we executed our, it was in the pending mode when we executed our code. That's why it's logging promise pending. We have to wait for this promise to resolve. Say await the resolution of this log the result to the console, and then we have 5. So this is use import modules asynchronously, and here we can say util add. So I forgot to export. So we can actually import everything. And now everything works as expected. And we can say import everything in that file as util. Util. Okay. Can't do this in here because this is a named variable. We can do something. Import everything. You can do something like import from util.js like this. And variables, function, or classes you want to call, you must, first of all, if you want to access them, you can do something like is equal to util. You can destructure it like this. You can say add. You can destructure, or if you want to, you can actually use, if you want to use or add, you can say util add. Yeah, you can do the same thing. You can actually say add is equal to our add without calling it from the util object. Then we log this to console and we still get our which is really nice. Okay, so asynchronously import modules and moving variables. And we've actually seen how we can import default and named variables. Module loading. How does module actually, how are they loaded and how are they loaded? So you have to pay attention to this. But basically, if you don't want to pay attention, and okay, so by paying attention, I mean just listen to what I'm trying to do, and you can come to module loading. Here we have module loading. So all the examples I've been using, I actually modified some, but all we have here, I've commented some things, and you can go ahead and try to use. Even though demonstrating, they are quite similar. So you can just modify things. And I actually forgot to rename import. You can actually reference this Oxford reading on your own. You can actually rename it as you like. Okay, so now I want us to read this together because taking it off head may cause a little bit of confusion and you may not understand as it is. So here it says in the ES6 modules, the process of loading and executing modules is handled by the JavaScript engine. So module resolution. So after this, you have to actually go over the docs again, but then when you use import statements in your code, the JavaScript engine or module loader needs to find the corresponding module file. Of resolving the import statement to a physical file path on the disk. That is the reason why in our AMD to specify the directory name. That is the use of that directory name. It has a file path on the disk. So the resolution strategy can be influenced. The reason why we use that base URL in that AMD to specify directory, the directory name. The presence of base URL, the directory structure conventions following a node modules folder for third party. So fetching the module. Once the module file path is resolved, the path location. Okay, so this is what is being resolved. Let's assume we have the path now index.js. So the disk from the root, it will resolve to that. It reads the file. It needs to fetch the code from the location. It reads the file and then fetch the code. So this might it involves a simple file from the local file system or a network request for external modules served. Sweet. JavaScript is sweet. Even though it's sometimes a kind of headache, but I love JavaScript. So the first code is then passed by the JavaScript engine to understand the module structure. That is the imports, the exports, and all of that. Separate top level scope. And let me zoom in a bit. It's in a separate top and functions defined in other modules. So let me add something to this. A different module and you import it in, let's say, a global. That function is executed separately in its own imported in that global context. After execution, so during execution, if the module encounters import statements of its own, can you see that? If the file import that file and the module you are trying to resolve, that module you are trying, let's assume there's a function inside, and in using that function, something that is imported from another module. So that is when, if the module encounters it does that, it will still need to read the content from that place where they have to read the code, bring it to the function, execute it before returning to the global content. Module loading is typically handled by the browser's built-in module loader. Might introduce custom module loader that performs additional tasks like code build into a single file, code transformation, and dependency management. I will see to that in a bit. Typically loaded synchronously by default. This means the execution of the current module is post loaded and passed. So, however, some bundlers and module loaders synchronous loading, where the import statement returns a promise that results when the module is ready. As what we just did in that code. Okay, so we've just seen how module being done. So if really you don't understand what you've just read, and it's a kind of, and if you can have any, if you have any questions, Discord is widely open and always available to answer your. And before we proceed, I want to mention this. How is it? I've forgotten the actual imagination or that the mentality that you feel it will affect you. You must actually know what's going on before proceeding to the next thing. Don't just I grab the basics, let me just move on. No, you don't have to move on. Because in the long run, you don't want to just build a framework. You actually want to contribute to the JavaScript echo people will use in their code. And how can you do that if you don't even understand all these basics? We have circular dependencies. So what are circular dependencies? This one confusing, but then let's briefly take a look at what circular dependencies are and how they occur. Dependencies occur in JavaScript modules. There's when two or more modules circular dependencies occur. So let's assume that it's imported from math. Now that you multiply that is imported from add. So add depends on add. That is a circular dependency. So when the JavaScript modules, so it gets stuck in a loop. So module A waits for B for the add module to load, and in turn, the add module waits for the kind of construct a loop, an infinite loop. So it might get stuck in an infinite loop, preventing the application from running because this will wait for this one to load, the other one waits for that one to load, and they continue loading and loading and loading without. This also causes modules not to be loaded completely before execution. So there are ways we can prevent, which is not good. So let's demonstrate a circular dependency example. We'll do this see how we can prevent that actually. We will import about 3 functions. We export add, and this affects A, B, returns A plus B. And what we do is copy the function and paste again. But this time around, it's sub, and it returns A minus B. And in this one, we have, and this one, what it does is it returns a function. This function, it's in the, let's say it's in the util file. Let's import multiply, let's say more util file, but then we don't have that multiply there. But we can see what you can actually do here. You can see apply 2, 3 of our util.js. Let's do away with. Instead of a util.js, we can do something like, we can import the add, import from, let's say this is it's in the max. We can import, and inside of this we can say export function, and this function we call it more. The more we're using in the math file, the math.js file. So this more takes in a parameter, return, or this more actually returns add. And this add A, B multiplied by A multiplied by B. Multiplied by 3, something like that. Okay. So now what we will simply, this is the util file, and in our index, yes, we want to make use of that. Let's do away with this. Let's import test. Actually, not cause an error. I just wanted to show you something so you can know what. More. And do something like result 1 is equal to sub and const result 2 is equal to should we say test, let's just say test because it's a test function taking argument. Tests, okay, no, I'm not utilizing the power. Say you can call the test and result 3 is equal to 3, like this, and then we can log result 2, result 3 to execute our file node index. Okay, so we're now not causing an error because this is a simple kind of demonstration. It's actually not causing an error. But look at what is happening. We have a multiplication function here that depends on the add function. And this add function is coming from this file, this math.js file. And in this math.js file, we still have a multiplication. This we still call this multiplication on this test. So this is actually a circular dependency. This one here depends on the math, which is not advisable at all. And then we execute this. How can we do away with all these cyclic dependency issue? We go ahead and try to create other files. At this test function, we extract this here. And then we have another file, let's say in this multiply file here that takes in another argument, and then add in this function. But then let's eliminate this as well. But depends on the util function. Nothing in the math function depends on it. It's only the util on this function in the, and that's quite all right. Okay, so understand what circular dependency is. And moving on, we have module bond. So we mentioned module bond last in solution. So module bundlers are kind of very important in JavaScript. And code structure and all of that. That processes our JavaScript code along imported modules. And then it combines them into one or more optimized files in Node environment or anywhere you can use. So it addresses many like multiple files, dependency management, and code optimization. So from numerous individual JavaScript files. So because you have to wait for the browser to load code from this file, so it will take time. So dependency management, manually managing dependencies between modules can be complex. Project you're building, and code optimization of browser performance. So how do they actually work? How do module bundlers work? So there's an entry point, an entry point for your application. So that is the entry point where they start processing from that file up to other files that are imported in that entry point. The next thing that happens is the dependency resolution. So the bundler traverses the entry point by analyzing import statements. So it has, after that, it transforms code, not, but most module bundlers transform code. So it transforms code, like it transpiles ES6 to ES3 or ES5 for older browsers for code standards and identify potential issues. The next thing that module bundlers do is bundling. We've said actually under bundling. So the bundler combines the code from the entry point, three polyfills into one or more optimized bundle. The kind of, because when code is in a single engine, the JavaScript engine doesn't have to go around searching for code in different splitting. It also splits code that into smaller bundles that can be loaded on demand. Code can be loaded to get in loading a module asynchronously, that module will only be loaded. If you don't call the add function, that asynchronous module will not be loaded. So it is being loaded on demand. Minification simply means removing unnecessary white space and comments from the code to reduce its file size. Module bundlers include improved performance, simplified dependency management, HTTP request, code organization, code. So apart from, we have popular Pack is one of the most popular. Which is ES build. I don't want to talk about ES build, but it is very super powerful. We are not going to go deeply into module bundlers, but I want you to recommend ES build if you are to choose any module bundler. What ES build is, and then pick up from there. So choosing the choice of module bundler depends on the project complexity and all of that. I think I included this in the docs. You can go ahead and read it when to choose your module bundler, all of that. It is my number one choice. Okay, that's it for module bundlers. The main idea behind module bundlers and all of that. You can you'll be reading that docs, you'll be shaking your head. Oh, so this is what module bundlers do behind. So another concept in modules is three. So it's actually not common. It's common in Java. You may hardly come across the term tree shaking. It's just an optimization technique that removes unused code from your final bundle. So the result is smaller. It's a smaller bundle size. It's that web applications. So just let's assume you have 100 directories, 1,000 files, and all of that. That is huge. That is, oh, the user experience will be very, very bad. Most of them support tree shaking behind the scene. So what is this? What we call static analysis. During the bundling, it examines the code. So after examining the code structure and export statements within your modules, not imported or used by any other part of the application of that. And also code with if or switch statement to conditional checks. So after identifying all unused code is then removed from the final bundle. That is a kind of a thing in the module bundler. You can it's being removed from the bundle. I really don't know. And it removes those code, the code that is not used, the unused code is known as those dead leaves then fall off. They fall off from the tree. But if you the kind of, let's say, expired leaves, they will fall off. So if you checked the Java, so benefits of tree shaking, we have reduced bundles, cache utilization. So how do we Tree checking, as I said, it's enabled by default in most, or you may need to ensure you are using ES6 module effectively. That's if you want to enable tree checking in your code. So it also has some limitations. Static analysis might not always be perfect. Code that appears at one time, leading to potential issues. That's one of the problems. Dynamic imports might pose challenges for tree checking to accurately identify and use the whole idea behind tree checking. And as depth about all these concepts, you get to understand that all these are very, very important. These considerations in mind, you have to consider every aspect of for writing complex code. Okay. Module interoperability. Sorry about the interoperability. This refers to the ability of modules written in different languages or environments to work together. You can actually visit the docs and see some. If you are building a project and one of them is written using AMD, the other is written using ESM. That's where module interoperability comes in. So this has to be coupled in order to work. So I believe we understand very well what modules are and how they work and all of that, how they can save our lives in coding JavaScript and the rest. We have promises on our list. Of us have been waiting for this, and we've actually used promises and how they work under this behind the scene. So promises are just and I call generators asynchronous. We actually use promises to accomplish that. So async awaits part of promises, but they were introduced in ES or ES7. I will get to that in a bit. But ES8 or yes. Promises are actually objects that have to wait for code to finish. And after the code is done executing, it then resolves or rejects. It resolves a value or so states and all of that can be pending, resolved, or rejected. When they for a result to resolve or for an error to reject, that state, as I demonstrated earlier by logging that console, and it was a promise, it logged a promise, and the promise was in the pending state. Let's see how promise can be, let's demonstrate the basic syntax of a promise. The promise is an object, so you can call a promise promise with capital letter, promise.or or promise.or set to promise or and all of that. Or you can see const promise, and this actually takes in a function. If you are invoking a promise instance, what it does is it takes in a function. It does in a function, and then that function takes in arguments. Arguments, they resolve and they reject arguments, which are them. So what this does under the hood is, if it will be resolved, but if it is not successful, so now represents the eventual completion of an asynchronous operation and its resulting value. Allows you to write code that appears synchronous even when dealing with what promises allows you to do. Then we have 3 states of promise. We have the initial state, that is the asynchronous operation is still ongoing. Then we have the fulfilled, that the operation encountered an error, so it couldn't be completed. Okay. 3 states of promises. So how can we create promises? To create a promise object. Okay, let me just see. Let's type of promise. Okay, it's a function. And the reason why a promise is a function is because this is a constructor function to declare constructor function to create a promise object. So the constructor function takes an executor function as an argument. So that is the inner function, which is known as the executor function. It has 2 arguments. They resolve and function that call when the asynchronous operation succeeds and resolved. The reject function is called when the operation fails. Use promises. Let's say, for example, we have a function that checks, let's say check even number. And inside of the function, it simply returns promise. And this new promise then takes function. This is the executor function in here. Look at the syntax. First of all, we have our promise here. New. The next thing is an executor function, which is actually an anonymous function. And this executor function can function like this. And then you can pass in the resolve and the reject arguments, which are themselves functions. But this is a kind of awkward. So what we need to remove this, and here we can specify what do you want this executor function to execute, because this executor function has some work to do. So what is it going to do? So what we need to say, if type of number is the number argument with this parameter here. number. We want to reject error. What this error says, input must be, and this is the function we used to demonstrate earlier. Then we say else. We have else if equal else if, like so, and then finally if the number is an even number. And how do we check even number? We say if number, if you divide the number by 2 and then the remainder is actually 0, then the number is an even number. And any other programming language. So if you divide an even number, so this will be resolved. Now we resolve. You see, okay, the number here, and even else, if it is a number, if it's not divisible by 2, that is, the number is not even, they will also reject, because one new error. Say the number, okay, let's just and bring it down here and say the number is an odd, like this. So now we've written this promise. This is a function, what running the promise. Now, if you call this function, what it will do is it return this promise. So how do we consume promises? You use the then and catch methods to handle the resolve value or reject reason of a promise. So when you call this method is called when the promise is fulfilled. So the callback function actually and you can also perform promise chaining, but we'll see to that in a bit. So the catch block that receives the rejection reason or what causes the, okay. So how do we now use our function? Now let's see, check even name, then we pass in, log this to the console, log check, oops, like this, check even name. If you log this to the console, this is a promise, it's actually resolved, but then we have it's a promise and what we want is the value, not actually the number. And so if you call the then method, this thing here, this resolved value, which is a string, will be passed to the then method, which the callback function will receive. It happens that this function is taking time to execute. You see here that the promise is pending. But here, there's no, you are just actually trying to show the basic usage of promises. But if out or it's fetching data, you see here that this promise is actually resolving. So we call this, then let's do away with this console log here. You say dot then. So this dot then takes in and this callback function, it receives the value. This value here is, let's say let's say it's the message, which is the string, and in here we log the message to the console, like so. 4 is an even number. That's sweet. So what if an error occurs? Now let's, for instance, see what we pass in here is 3 and not 4. Now this error happens. The number 3 is an odd number. But look at where the error is being thrown. Reject, this way it's this is not propagating this error to this function call. It's actually rejecting it directly in this promise. So we want to actually handle this error here and not in the. And in this catch, we have the error, and we simply log the error on the console, like this error. This arrow is pointing, new error, the number, and this is where this error is thrown. It's in the new promise, and then it was okay. So now let's see where this error will be thrown now. Okay, error, the number 3 is an odd. Index 8, JS 814. We are now handling this error here, not directly here. Now we did not reject new error statement. What should I call it? We no longer see it. What we see is the direct message, which is error, and the error is the number 3 is an odd number and not a number. Now, if we do this again, we have input must be a number, and we're handling this error. Finally, and this finally takes in the callback function as well. And you can see log. Oh, finally, we are done. Something like this. So if you execute this once more, now as you can see, we have an error, but this also executes. So this doesn't care if it's an error, the value is being resolved. This would be called. Let's, for instance, change this to 2 and execute our code once more. We have the number. Okay, so that's how, if you want to actually, if you want to execute something, even if there's an error successfully resolved, you can actually use the finally method and pass in the callback function to actually handle that which you want to do. Okay, so that is basically how we can use we are simply logging this error to the console. And you can do something like throw error. Now let's do this one. 3, and then run this again. As you can see, this is pointing back to here, because when you throw this error, there's nowhere this error can be handled except here. Back to this promise, and it will be handled here. So you don't, before you throw an error, just make sure this where you want to handle error so that it can be catch somewhere here and then handle something like that. Okay, you can do something like throw new error. Let's say this is not a number, an even number, or not a number at all. Like this. And then we have this is not a number. This is not an even number or. Okay, and look at where it is being handled. On line 18, index.js file line 18. Can you see where it is being handled? Throw the error, like, let's just throw it like this. Let's execute it and see where it's being handled. And here is our line 4 where we're trying handling errors here. Okay, so that's basically that. And in here, You can reject, see, reject like this. Then this is not an even number or this and that, or you can say throw new error, and in here you can just pass in the error. Now if you look at the number, look at where we're handling this line 18. Input must be a number. So we are throwing this error, but we want the original error message. Error message. We are rejecting the original error message, and then we are capturing it here, and then we are throwing this error with that error message. Okay. Promises, the promise states, how we can create and utilize promises. And oh, we have actually gone far. Promise states, how to create promises, and then we jumped promise chaining to handling errors. Learned how to handle errors, and we are going to jump handling errors to promise, or when we get to handling errors. When you learn how to chain promises, and chaining promises, let's assume more than one promise. Let's assume we have, let's say we have a promise that depends resolves. The following promise will also be resolved. Okay, let's for instance say we have we simulate this, get user, and we pass in the user ID. And in here, we will return a new, and this promise simply takes in an executor function and reject as arguments. So in here, time out, callback function, and then the timeout, let's say once callback function, see resolve ID of 1 and name of let's see KodeCamp, name of KodeCamp. So in here, after getting the user ID, what you want to fetch post, but this fetch post is also a promise. It's another function on its own that returns a promise. So we have function get post. This post takes in a user ID, because after returning the user, I want to extract this user ID from the user and then pass it here to actually get post. Takes in an executor function. This executor and reject as arguments. And in this executor function, what set timeout that takes in the callback, let's see, 1.5 seconds. And what it actually does, it's an array post 1 1. Let's just copy paste this, the user ID is 2. Now we want to change this, we want to use these two promises together. So how can we actually use we can use these two promises to on this coming now. Okay, now we want to use this from two promises. So we pass in an ID of let's say 1. Then we say then when it is resolved, it will resolve with a user. So let's say user. What we want to do is we want to let's say log user. After that, we want to grab. So we want to say in here return another promise post, and then we pass in user this, and this is promise check that takes in a callback function like this, and what is returned is post. End function returns a user. We grab the user ID from the user and that user. Then we see log post, and it's time to handle catch if an error occurred during the process. We log the error to the console. Now let's execute our function. It should take 1.5 seconds to complete. So first of all, the first promise resolved with the user of one name, and name is KodeCamp. To actually fetch the user post, we pass in the user, pass which user post when we return an array of posts. Okay. Error like this, and if there's an error, let's say post. Okay, so the first one gets resolved, but the second one, the post is undefined. Error about on line 32 column 31, line 32 here, and column here is 31. Yes. Okay, so let's change it back to post. So that's basically how we can chain promises. Okay, so moving on, we've seen an example of how we can chain promises. And next on the list is promise or. This is a static method on the promise object. Promise or. And what this method normally does is iterable of promises. That is either an array or any object with a symbol for iteration. What we earlier learned, you can just imagine how that is happening. So it takes in an iterable of as its argument and returns a single promise. What it simply does is it waits for all the promises in the iterable to settle, that is to resolve or reject. So if all promises resolves with an array containing the fulfilled values of each promise in the original iterable in the same order. If any promise in the iterable rejects, the returned promise immediately rejects with the reason that in the iteration order. Okay, so let's basically see how promise or works. Let's say we have our first promise. A new promise resolve. And what it does is the callback function that resolves with resolve promise one result, like so. in 1 second. So this is our first promise. Now what we'll do is we copy this promise here, and then we'll make it about second promise, third promise. So all we need to do now is change the name to 2, change this one to 3. Then we'll say promise 3, let's say rejected. And then we say here we have reject, and then we say reject like this. So now we can use, or we can use promise or. Okay, let's just say promise. Can use promises, and this will take in arrays of let's say promise 1, promise 2, promise 3. Then if it resolves that, then it takes in the, let's say, the values. And inside of this callback, we simply say log. Here we can do something like dot catch error. We log error on the console. It's error, not error. Okay, like this. So let's execute our code and see. Rejected. The reason why, because first, it waited for promise 1 and 2 to execute, but after being executed, this what you want is for all the promises to be resolved. So one of them rejected. So what we log on the console is promise 3. So we logged the value promise 3 rejected on the console. But let's assume promise 3 like so. And then we log it to the console. After 1 second, we have promise 1, promise 2, promise 3, or we can change the time here to 1.5 seconds, and then we can change the time here to 2 seconds, so that we can see how all these promises are. After this one will wait for this one to be resolved. After this, it will wait for this to be resolved before the values will be returned. So let's execute this. 1.5 result. So what promise or does is wait for all the promises to be resolved before the values are returned. So with using async, I will something like once values is equal to await promise or, and in here values like this. And if you run this function, after 2 seconds, we have our values. And this is an array, so we can do some of values. For attribute, then we say as simple as it is, and then this. Promise 1 resolved, promise 2 resolved, okay. And then after promise or what? And what promise or does is wait for all. It takes an iterable of promises over iteration. But unlike promise or, which waits for all, for one of the promises in the iterable to settle, that is to be rejected or resolved. Checked with the reason from the first rejected promise encountered in the iteration. They are just of no use again. Example to look at, you look at promise race, and instead of race like this, and then and you can see it is the first promise that's resolved. So okay, let's change this to 1.5 seconds and then change this to 1 second, and then let's promise race is log to the console. After 1.5 seconds, promise 1 resolved, and this is promise 2. Promise 2 resolved. Okay, it's resolved, not even resolved. Okay. Promise 2, and then it's returned, and the value of promise 2 is being returned. But then let's reject this promise like this, and then run it again. Promise 2 resolved, and that's all. Okay, now let's change this to 1 second and see what happens. Promise 2 resolved. 1 second, that is the first one. Okay, change this one. Should be the first one to be rejected. Promise 3 rejected. Resolved. Run it once more. Then you see promise 3 rejected, because this is the first reason will be returned and code execution will terminate. And we can also use async await to promise race. Best practices, you can go ahead and then learn the best practices in the docs on your own. To an end of promises. And moving forward, we have async await. These are added sugar to promises. They're added sugar to promises. So instead of writing promises and chaining promises and doing all, mark the function as async. And so when the function is marked as async, provides it, what it does is it's like, it's not like the traditional promises. So when the function, the function, it then waits for the functions inside of it to finish execution first before that function will run. So what happens is, if you declare a function with async keyword, it makes the function asynchronous. So the await inside of the async, you can use. So this pauses the execution of the async function until the promise settles, whether it resolves or it rejects. So async await doesn't provide a syntactic layer on top of promises to make asynchronous code appear more synchronous and easy to read and write and all of that. So that is just okay, let me see. Let's see if you can undo to the example we used earlier. This will take time. Okay, but let's see. I don't want to type in any code. Okay. Maybe it will work. If not, then we have to type in something. I just don't want to type an example I gave. Is it this one? Not this one. Continue on doing. Okay. So this check number function. So what we can do here is this, a promise is asynchronous. So we can promise inside. So it's asynchronous, async function. And then this function, actually, what it does is it const even number await because it is being marked as async. So you can use await inside of it. Then you can say check. In here, you can say log even number, like so. So when we execute, we log this console have the number 4 is an even number. So if you remove this await keyword, it's actually a promise. It has resolved, but you are not awaiting for it and you're not getting the value. So you must use the await keyword in front here. This to 4 like this, and then run it again. So this time around, it's being handled here, but not, we're not handling it here. So for us to handle this error here, we say try, include the try catch block. And instead of logic, and in the catch block is to handle errors. You can simply say log error on the console. Catch block and the error will be handled there. So now let's run this once more and see where the error is handled. Okay, so now this is logged to the console and it's handled here. And if you really want to know that it's handled here, you can simply say throw error. Like so, and then run this once more, and then we have an error, but this time around we have throw new error, and then we have error. We have an error here, throw new error, and then here is the actual error found in the line 18, column 11. That's where the error. Okay, so that is basically how to handle errors in promises, and that's how asynchronous functions work. If you don't want to use promises by chaining, by using async await, if you don't want to do something like then and all of that. And inside of this, you can also then with the value. Yeah, you can say log net this one, and then run this function once more. This time around, make this. Since this is a synchronous function, so without even using await, that is the reason why we see await is just a syntactical sugar. It's like this. And if you don't want to propagate this error down to this level, you can say dot catch error. Log, I say error. You can say local error like this. Yeah. So let's run this. This is error. I'm always making this mistake. Error. And then let's run our code and change this to run it. And this time around, we have an error here. The number 3 is an odd number. As you can see, we have local error, and then we have an error, then we have. So what we are doing here, we are not propagating this error down to this point. We're actually catching it here. But if you don't handle this error here, it will be propagated to this catch block. Now, if you eliminate this block, and it will be handled there. The number 3 is an odd number, and then look at it is handled. Okay. Because this is, you are calling this, and then this is referencing this check even number. So it will be handled here, not in the catch block. Sorry about that. It will be handled here, not in the catch block. Only when you use await in the value is equal to like this, that is when the error will be handled in the try catch block. Now, if you run this, you can see that the error is handled. What is this? Okay, so what's happening here? And then, okay, so now let's change this to a string and then see. Okay, so V, like so, and then what we have here is input must be a number, John error. Error, we're missing the await keyword. Okay, and now we are handling our error. Okay, so for the best practice, to see how we can use effectively. So in our today class, we see the different module system, the ES and ESN. We also see how we can import and export modules. We moved over to promises, and then we looked at methods and how we can effectively use promises for asynchronous operations and await to add syntactical sugar to promises and to make our code more cleaner. Actually understand everything. And after that, we move to the end of our class for today. And if you have any questions, please don't. We can interact more better and try to solve our problems as well. You can always reference my GitHub channel where the docs are. Read the docs. You can hit me up on Discord channel, and I am always ready to assist. So thank you for joining. Meet in our next class.